So this is 5.2b, and we're ready for example number 3 here. And let's go ahead and put some of these down. It just says simplify. So we have x cubed over 2. Okay, what does that mean? Well, first of all, I have to write the problem right. All right, it's in parentheses. So whenever something is in parentheses and there's an exponent, that exponent applies to everything in the parentheses. So this one, we put 3 on the x, 3 on the 2, and we get x cubed because we don't know what x cubed is. So whenever we have a variable with an exponent, it doesn't change, and we cube that, and we're done. All right, when we have 5 over y, and the quantity is squared, that again becomes 5 squared over y squared, which is 25 over y squared. And c, 2/3 to the 4th power, that equals 2 to the 4th power over 3 to the 4th power. So this is going to be 16 over 81. Okay? And that brings us to the next part of this, zeros as exponents and 1 as exponents. Now I could go into all the theory for you and explain how it works and why it works, but gosh, I think that you're just going to be happy just knowing that it works. Anytime you have an exponent of 1, it equals the number the exponent is on. If I have 3, 1, that means it equals 3. If I have 4x squared y cubed z to the 5th, and that's all in parentheses, and there's a 1 there, since the 1 is the outermost exponent, my answer then will be whatever is in the parenthesis. Okay? It just means it's itself. All right, so when the exponent is 0, what do we get here? We get 1. And I guess I will explain how that works. 8 to the 0 is 1. 3x squared to the 0 power is 1. 3x squared y to the 5th z to the 27th over 14x squared a cubed w to the 15th. And if I put that all with an exponent of 0, it equals 1. This whole stinking mess is, if that's a 0, equals 1. Okay? So let me explain to you why that works. So let's start with 1. 1 is any number over itself, right? 1 is any number over itself. 1 is any number over itself. So whenever the numerators are the same as the denominators, we get 1, correct? Yes. So what is the exponent on, well, let's look at the middle one here. What is the exponent on these? 2. And how do you solve this? You take the first one and you subtract the second one's exponent. What is 2 minus 2? 0. So 3 to the 0 equals 1. That's the theory behind it. You don't have to know all of that, just be able to do it. All right, which brings us to some examples. In fact, let's look at example 4, part C. 4 to the 0 power, 4 to the 0 power, plus 4 to the first power. What did I say 4 to the 0 power is? Any number to the 0 power is 1. Any number to the first power is itself. Okay? 2x squared y to the 0 power. What is the outermost power? 0. Our answer is 1. Okay? And that's the 0 and 1 used as exponents. So let's look at a bunch of examples here. See if we can make sure we clear up any struggles along the way. So examples, number 5, 5x cubed, and we're squaring it, and we're going to put that over x to the 4th. This is going to be 5 squared x cubed squared over x to the 4th. What's 5 squared? 25. X cubed squared, multiply x to the 4th. Now, if you want to do what I did before, smallest exponent is 4, get rid of that, get rid of 4 of those, and we have 2 left over. And we're done. 6, x to the minus 8th over x squared cubed. Okay, so let's do what's in the parentheses first. Okay. And this negative, there's a couple ways of doing that. That negative tells me that that's in the wrong place, so we're going to move it down with the x to the 6th. And then, because they're in that position, they're multiplied, we're going to add the exponents. And we're done. Alright, let's look at 7. It gives me y to the 5th over y cubed squared. Okay, so because we squared, we're squaring that and that. So we're squaring each of the ones. Okay, squared each one. 5 times 2, 3 times 2. Okay, now I look at these. I have the same bases. I have y's. So that means I can reduce this. The smallest one goes away, and I can take 6 away from there, and I have 4 left over, and I'm done. Alright, let's keep plugging away. And again, if I'm going too fast, just slow me down on the video, or watch it again. Okay, there we go. So let's go ahead and put that on each one. Okay, put that in parentheses. Okay, so what does that tell me? It's telling me that the 3 and the 2 are in the wrong place because of that. It's telling me that the x to the 5th and the 2 are in the wrong place because of that. So let's move them to the right place. And when I put them to the right place, the negative comes off. Whoops, I don't want to do that. Nothing on top, so we put a 1 up there. So that gives me 1 over 3 squared is 9, x to the 10th power. Alright, brings me to number 9. Okay, multiplying. The exponents are on the same level as each other. Now if you look up here, when we were doing these, see they're on, this exponent here is higher than this. There's nothing between them except that parenthesis, whereas here there's an x between this and this. So that helps to remind me that I'm adding. So I end up with x to the negative 8 plus 5, which equals x to the negative 3, which tells me that this x and the 3 are in the wrong place, so I need to put them in the right place. So I'll make it a fraction, and I'll move the x and the 3 to the bottom, and leaving me a 1 on top. Okay, let's do one more. Let's do number 10 here, and then we'll go on to some new stuff. Number 10 is a cubed squared, a to the negative 4, all over a to the negative 4 cubed. Oh, goodness. Alright, so we're going to do this first. And we'll do this. So notice what happened here. Negative 4 times a positive, or cubed, is going to be just 4 4 times 3, and give me the a to the negative 12. All right, so what do I know? This is in the wrong place, and this is in the wrong place. So I'm going to take this and move it down, and this and move it up. Because that's the only thing that negative tells me, remember, is that the a to the negative 12 should not be in the bottom, it should be on the top. A to the negative 4th should be on the bottom, which makes all my negative signs go away. Now I'm going to multiply those and get a to the 6 plus 12 is 18 over a to the 4th. That equals, get rid of all those, get rid of 4 of those, and that leaves me with a 14. And that's what I've got. Okay, so let's do some applications. Alright, so example 11. Suppose you have two squares, one of which is larger than the other. If the length of a side of the larger square is 3 times as large as the length of the smaller square, how many of the smaller squares will it take to cover up the larger square? Okay, so here's my two squares. Now remember, the larger one is 3 times as long as the smaller one. That's why the 3x, to show 3 times as long. Alright, so if we let x represent the length of the smaller side and 3x represent the length of the bigger side. Okay, we've got our diagram here. So, let's see what we're supposed to find out. How many of these squares will go in this one? Okay, now you could draw some cool pictures here and go, well, if this is x, if this is, let me get my drawing right. If this is x and this is 3x, then I can get basically 9 of them in there because I've got an x, an x, and an x, and an x, and an x, and an x. Okay, that's the geometric way of doing it. The algebraic way of doing it is going to be a little bit different. So, using algebra, we're trying to find out how many of these areas are there in this whole area here. Okay. So what we're going to do is we're going to divide the area of this square by the area of this one, and that'll tell us how many of these will go in there. So what is the area of this square? Area of a square is length times width. So the big square is 3x times 3x, which is 9x squared. The area of this one is x times x, which is x squared. So now we just divide. So we have 9x squared divided by x squared. Those cancel, give us 9, and we're done. Now this one is example number 12, and it's the same thing, only we have cubes. So it's asking how many of these smaller boxes will fit into this big one. So in the last one we just took length times width because it was area. Now this one's volume, so we have to take length times width times height. Gives me 3 times 3 times 3 is 27, x cubed. This one here is x. So we do the same thing. The volume of the big one divided by the volume of the little one. Cancel, cancel. 27, and we're done. Okay. Let's look one more minute on scientific notation, and then we will be done. I may have to go into a third video. We'll see. In fact, I'm sure we will. So I'm just going to stop now and go into more on scientific notation, which will be, remember we did big numbers, now we're going to do small numbers.